Tuesday, August 29th, 2023. Topic: List of prime numbers. Please pardon any visual and informational inaccuracies in this entirely AI-generated video.
This article presents a table of the first 1,000 prime numbers and discusses the calculation and estimation of prime numbers using formulas and the Riemann hypothesis. The table provided contains the first 1,000 prime numbers arranged in 50 rows with 20 columns each. The Goldbach conjecture verification project has calculated all primes below 4 times 10 to the power of 18, which amounts to approximately 95,676,260,903,887 primes. However, these primes were not stored. There are formulas available to compute the number of primes below a given value faster than generating the primes themselves. Using these formulas, it has been determined that there are roughly 1,000,925,320,391,606,803,968,923 primes below 10 to the power of 23. Another computation, assuming the Riemann hypothesis is true, found that there are approximately 18,435,599,767,349,200,867 primes below 10 to the power of 24. The article provides a list of the first prime numbers for various name forms and types. It specifies that n represents a natural number, including 0, in the definitions. For more detailed information about each specific name, readers are encouraged to refer to the article. The given sequence consists of prime numbers that have equal-sized prime gaps above and below them. These primes are equal to the arithmetic mean of the nearest primes above and below them. The sequence starts with 5 and includes numbers such as 53, 157, 173, 211, and so on. This sequence is represented by the OES identifier as 006562. The given sequence consists of prime numbers that represent the number of ways to partition a set with a certain number of members. The sequence starts with 2, 5, 877 and continues with larger prime numbers. The next term in the sequence has 6,539 digits. This sequence is known as a 051131 in the OES, the Online Encyclopedia of Integer Sequences. The given list consists of prime numbers p such that p plus 2 is either a prime or a semi-prime. The list starts with 2 and continues with various prime numbers such as 3, 5, 7, and so on. The list is not exhaustive but provides a sample of such prime numbers. A circular prime number is a number that remains prime when its digits are rearranged in any order. Examples of circular primes include 2, 3, 5, and 11. Some sources list only the smallest prime in each cycle, while others include all circular primes. All repunit primes are also circular primes. A cluster prime is a prime number where every even natural number less than or equal to p minus 3 can be expressed as the difference between two primes that are also less than or equal to p. All odd primes between 3 and 89 are cluster primes. The first 10 primes that are not cluster primes are 2, 97, 127, 149, 191, 211, 223, 227, 229, and 251. D. The given sequence consists of pairs of prime numbers where the second number is always 4 greater than the first number. The sequence starts with 3, 7, and continues with various pairs such as 7, 11, 13, 17, 19, 23, and so on. This sequence is known as OEIS A023200 and OEIS A046132. The given expression is of the form open parenthesis x cubed minus y cubed close parenthesis divided by open parenthesis x minus y close parenthesis, where x equals y plus 1. The sequence generated by substituting values of y into the expression is as follows: 7, 19, 37, 61, 127, 271, 331, 397, 547, 631, 919, 1657, 1801, 1951, 2269, 2437, 2791, 3169, 3571, 4219, 4447, 5,167, 5,419, 6,211, 7,057, 7,351, 8,269, 9,241, 10267, 11719, 12097, 13267, 13669, 16651, 19441, 19927, 22447, 23497, 24571, 25117, 26227, 27361, 33391, 35317. Similarly, when x equals y plus 2, the sequence generated is as follows: 13, 109, 193, 433, 769, 1201, 1453, 2029, 3469, 3889, 4801, 100931, 22889, 13873, 18253, 20173, 21169, 22189, 28813, 37633, 43201, 47629, 60493, 63949, 65713, 69313, 73009, 76801, 84673, 106033, 108301, 112909, 115249. The sequence is of the form n times 2 to the power of n plus 1. The first term is 3, and the second term is a very large number: 393,050,634,124, 102,232,869,567,034, 555,427,371,542,904, 833. This sequence is known as OEIS 050920. The given list consists of prime numbers that remain prime when read upside down or mirrored in a 7-segment display. The list includes numbers such as 2, 5, 11, 101, and so on. These numbers have the property of being palindromic or symmetrical when displayed in a 7-segment format. The list is part of a sequence known as A134996 in the OEIS, Online Encyclopedia of Integer Sequences. The given list consists of Eisenstein integers that are irreducible and real numbers, specifically primes of the form 3n-1. The list includes numbers such as 2, 5, 11, 17, 23, and so on. These numbers are considered irreducible in the context of Eisenstein integers, meaning they cannot be factored into smaller non-unit Eisenstein integers. EMIRPs are prime numbers that remain prime when their decimal digits are reversed. Some examples of EMIRPs include 13, 17, 31, 37, and 71. The term EMIRP is derived from reversing the word prime. A list of EMIRPs can be found in the OEIS sequence as 006567. The given sequence is a subset of primorial primes represented by the formula P sub n hash plus 1. The sequence starts with 3, and each subsequent term is obtained by multiplying the previous term with the next prime number and adding 1. The terms in the sequence are 3, 7, 31, 211, 23, 11, and 2005604903131. This sequence is also known as OEIS 018239. The given list consists of prime numbers that divide the Euler number E2n for some values of 2n between 0 and p minus 3, where p is the prime number. The list includes numbers such as 19, 31, 43, 47, and so on. The numbers 149, 241, and 2946901 are prime numbers that form Euler irregular pairs with their respective differences of 146, 238, and 2946898. These pairs are known as Euler irregular pairs. The given sequence consists of numbers that are either one less or one more than a factorial number, n factorial. The sequence starts with 2, 3, 5, 7, and continues with larger numbers. These numbers have a specific pattern and are listed in the OEIS database under the identifier A088054. The numbers of the form 22 to the power of n plus 1, such as 3, 5, 17, 257, and 65,537, are known as Fermat primes. As of August 2019, these are the only known Fermat primes, and it is conjectured that they are the only ones. The likelihood of another Fermat prime existing is estimated to be less than 1 in a billion. The only known generalized Fermat primes for a less than or equal to 24 are as follows: for A equals 2, 3, 5, 17, 257, 65537. For A equals 4, 5, 17, 257, 65537. For A equals 6, 7, 37, 1297. For A equals 8 does not exist. For A equals 10, 11, 101. For A equals 12, 13. For A equals 14, 197. For A equals 16, 17, 257, 65537. For A equals 18, 19. For A equals 20, 401, 160001. For A equals 22, 23. For A equals 24, 577, 331777. The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones. The given sequence shows the prime numbers in the Fibonacci sequence, starting from f0 equals 0 and f1 equals 1. The primes in this sequence are 2, 3, 5, 13, 89, 233, 1597, 28657, 514229, 433494437, 29712150073, 99194853094755497, and 106634041719510595814572172169. The sequence is also known as OS:A005478. The given list consists of fortunate numbers that are also prime. It is conjectured that all fortunate numbers are prime. The list includes numbers such as 3, 5, 7, 13, 17, and so on. The sequence is known as OEISA046066. The prime elements of the Gaussian integers, which are also primes of the form 4n plus 3, include numbers such as 3, 7, 11, 19, 23, 31, and so on. The list continues with numbers like 503, and it can be found in the OES sequence A002145. The list of primes that satisfy the condition p sub n squared is greater than p sub n minus I times p sub n plus I for all 1 less than or equal to I less than or equal to n minus 1 is 5, 11, 17, 29, 37, 41, 53, 59, 67, 71, 97, 101, 127, 149, 179, 191, 223, 227, 251, 257, 269, 307. The given list consists of happy numbers that are also prime. These numbers are 7, 13, 19, 23, 31, 79, 97, 103, 109, 139, 167, 193, 239, 263, 293, 313, 331, 367, 379, 383, 397, 409, 487, 563, 617, 653, 673, 683, 709, 739, 761, 863, 881, 907, 937, 1009, 1033, 1039, and 1093. The given list consists of prime numbers for which there are no solutions to the congruence equations h sub k congruent to 0, mod p, and h sub k congruent to negative omega p mod p, where h sub k is the kth harmonic number and omega p is the Wolstenholme quotient. The list includes primes such as 5, 13, 17, 23, and so on. This sequence is represented by A092101 in the OES. The given sequence consists of prime numbers for which the difference between the prime and 1 divides the square of the product of all previous terms. The sequence starts with 2 and continues with 3, 5, 7, and so on. The complete sequence is provided in the question. The given sequence consists of prime numbers that have more quotients, which are numbers that are not divisors, than any integer below them except for 1. The sequence starts with 2 and continues with 23, 47, 59, and so on. These primes have a unique property related to their quotients. The given sequence represents the prime factorization of numbers starting from 2 and iterating until a prime number is reached. Each number is represented as the concatenation of its prime factors in base 10. The sequence continues with larger prime factorizations until the last number 6,161,791,356,847,912,777,000, which is a prime number. The list provided consists of odd prime numbers that divide the class number of the p-teth cyclotomic field. The numbers in the list are 37, 59, 67, 101, 103, 131, 149, 157, 233, 257, 263, 271, 283, 293, 307, 311, 347, 353, 379, 389, 401, 409, 421, 433, 461, 463, 467, 491, 523, 541, 547, 557, 577, 587, 593, 607, and 613. The Wolstenholme prime is a type of prime number that was discovered by Joseph Wolstenholme in 1862. It is a prime number that follows a specific pattern and has unique properties. The Wolstenholme prime is named after its discoverer and has been the subject of mathematical research and exploration. The prime number 37 is such that open parenthesis 37, 32, close parenthesis is an irregular pair. The primes p equals 67 and p equals 877 are examples of irregular pairs, where p minus 9 is an irregular pair. This means that the difference between the two primes is not a prime number itself. These pairs are listed in the OES sequence A212557. The list of prime numbers p such that neither p minus 2 nor p plus 2 is prime is as follows: 2, 23, 37, 47, 53, 67, 79, 83, 89, 97, 113, 127, 131, 157, 163, 167, 173, 211, 223, 233, 251, 257, 263, 277, 293, 307, 317, 331, 337, 353, 359, 367, 373, 379, 383, 389, 397, 401, 409, 439, 443, 449, 457, 467, 479, 487, 491, 499, 503, 509, 541, 547, 557, 563, 577, 587, 593, 607, 613, 631, 647, 653, 673, 677, 683, 691, 701, 709, 719, 727, 733, 739, 743, 751, 757, 761, 769, 773, 787, 797, 839, 853, 863, 877, 887, 907, 911, 919, 929, 937, 941, 947, 953, 967, 971, 977, 983, 991, 997. The given sequence is of the form xy plus yx, where x and y are positive integers and x is less than y. The sequence starts with 17 and continues with larger numbers such as 593, 32,993, and so on. The sequence is known as OEISA 094133. Cyclic numbers, also known as full repten primes, are primes p, for which the expression b raised to the power of p1 minus 1, all divided by p, gives a cyclic number in a given base b. The primes p for base 10 that satisfy this condition are 7, 17, 19, 23, 29, 47, 59, 61, 97, 109, 113, 131, 149, 167, 179, 181, 193, 223, 229, 233, 257, 263, 269, 313, 337, 367, 379, 383, 389, 419, 433, 461, 487, 491, 499, 503, 509, 541, 571, 577, 593. The Lucas number sequence is a series of numbers where each number is the sum of the two preceding numbers. The sequence starts with 2 and 1 and continues as follows: 2, 3, 7, 11, 29, 47, 199, 521, 2,207, 3,571, 9,349, 3,010,349, 54,018,521, 370,248,451, 6,643,838,879, 119,218,851,371, 5,600,074,829,301, 6,888,465,025,889, 32,361,122,672,591. Some of these numbers are prime. These are some lucky prime numbers: 3, 7, 13, 31, 37, 43, 67, 73, 79, 127, 151, 163, 193, 211, 223, 241, 283, 307, 331, 349, 367, 409, 421, 433, 463, 487, 541, 577, 601, 613, 619, 631, 643, 673, 727, 739, 769, 787, 823, 883, 937, 991, 997. Mersenne primes are prime numbers of the form 2 to the power of n-1. There are 51 known Mersenne primes as of 2018, with the 13th, 14th, and 51st primes having 157, 183, and 24,862,048 digits, respectively. The largest known prime number, M82589933, is also a Mersenne prime. The sequence consists of prime numbers that divide 2n-1, where n is a prime number. Some examples of these primes include 3, 7, 23, 31, and so on. All Mersenne primes, which are prime numbers in the form 2 to the power of n-1, are also part of this sequence. The list of prime numbers p such that 2p-1 is also prime includes numbers like 2, 3, 5, 7, 13, 17, 19, and so on. As of December 2018, the sequence continues with 3 more numbers: 74,207,281, 77,232,917, and 82,589,933. However, it is not known if there are more numbers in the sequence after these 3. The subset of Mersenne primes consists of numbers of the form 22p-1-1, where p is a prime number. Some examples of these primes are 7, 127, 2,147,483,647, and 170 quadrillion, 141 trillion, 183 billion, 460,469 billion, 231,731,687 billion, 303,715,884, 105,727. These primes can be found in the OEI sequence A077586. The expression open parenthesis, a sub and -1 close parenthesis divided by open parenthesis, a -1 close parenthesis, generates a sequence of numbers that have special properties for certain values of A. For example, when A equals 2, the numbers generated are known as Mersenne primes. When A equals 10, they are called Repunit primes. The sequence for other small values of A is also listed, showing the primes that are generated. For some values of A, no primes exist in the sequence. There are various generalizations of Mersenne primes, including primes of the form b to the power of n minus b minus 1 to the power of n, and Williams primes of the form b minus 1 multiplied by b to the power of n minus 1. These generalizations encompass Mersenne primes and Cuban primes as special cases. The given sequence is of the form floor of theta times 3 to the power of n, where theta is Mills' constant. This sequence consists of prime numbers for all positive integers n. The first few terms of the sequence are 2, 11, 1361, 2,521,008,887, and 16,022,236,204,009, 818,131,831,320,183. This sequence is listed in the OEIS as A051254. The concept of minimal primes refers to prime numbers for which there is no shorter subsequence of their decimal digits that forms a prime number. There are exactly 26 minimal primes, including numbers like 2, 3, 5, 7, 11, 19, and others. These primes have the property that no subset of their digits can form a prime number. The Newman-Shanks-Williams numbers that are prime are 7, 41, 239, 9,369,319, 63,018,038,201, 489,133,282,872,437,279, and 19,175,294,298,032,928,599. These numbers are part of a sequence known as A088165 in the OEIS. The problem is to find prime numbers p for which the smallest positive primitive root is not a primitive root of p squared. So far, 3 such primes have been found: 2, 40,487, and 6,692,367,337. It is currently unknown if there are more primes that satisfy this condition. This sequence is listed in the OEIS as a 055578. The given list consists of prime numbers that remain the same when their decimal digits are read backwards. These numbers include 2, 3, 5, 7, 11, 101, 131, 151, 181, 191, and so on. The sequence is known as OEIS a 002385. Primes of the form open parenthesis a times open parenthesis 10 raised to the power of m minus 1 close parenthesis divided by 9 close parenthesis plus or minus b times 10 raised to the power of open parenthesis m minus 1 close parenthesis divided by 2 with 0 is a plus or minus b less than 10. These primes have the property that all digits except the middle digit are equal. Some examples of such primes are 101, 131, 151, 181, 191, 313, 353, 373, 383, 727, 757, 787, 797, 919, 929, 11311, 11411, 33533, 77377, 7747, 77977, 1114111, 1117, 111, 3331, 3333, 7333, 77727, 77774, 777, 7778, 777, 11118111111111 91111 777767777 7777767777799999919999999. The given list consists of prime values of the partition function. These values represent the number of ways to partition a positive integer into distinct parts. The list starts with 2, 3, 5, and continues with larger prime numbers such as 7, 11, 101, 17,977, and so on. These prime partition function values have been documented in the OEIS, Online Encyclopedia of Integer Sequences, as sequence A049575. The Pell number sequence is defined as P0 equals 0, P1 equals 1, and Pn equals 2 times Pn minus 1 plus Pn minus 2. The sequence contains prime numbers such as 2, 5, 29, 5,741, 33,461, and so on. The sequence continues with larger prime numbers like 44,560,482,149, 1,746,860,020,6,809, 68,480,460,468,746,969, and 13,558,774,610,46,711,780,701. The sequence is listed in the OEIS as a 086383. The statement suggests that any arrangement of the decimal digits can form a prime number. It provides a list of examples to support this claim, including numbers like 2, 3, 5, 7, and larger primes formed by rearranging the digits. The OEIS sequence a 003459 is mentioned, which likely contains more examples of primes formed by permutations of digits. The parent number sequence is defined by P0 equals 3, P1 equals 0, P2 equals 2, and P of n equals P of n minus 2 plus P of n minus 3. The sequence contains several prime numbers, including 2, 3, 5, 7, 17, 29, 277, 367, 853, 14,197, 43,721, 1,442,968,193, 792,606,555,396,977, 187,278,659,184, 172,324,321, and 662,411,604,328,810,715,798,647. This sequence is listed in the OEIs as a 074788. The given sequence is of the form 2u3v plus 1, where u and v are non-negative integers. These numbers are also known as class 1 primes. The sequence starts with 2, 3, 5, 7, and continues with several other prime numbers such as 13, 17, 19, 37, 73, 97, and so on. The sequence is listed in the OEIS as a 005109. The list of prime numbers for which there exists a positive integer and such that p divides n factorial plus 1 and n does not divide p minus 1 is as follows: 23, 29, 59, 61, 67, 71, 79, 83, 109, 137, 139, 149, 193, 227, 233, 239, 251, 257, 269, 271, 277, 293, 307, 311, 317, 359, 379, 383, 389, 397, 401, 419, 431, 449, 461, 463, 467, 479, 499. The given sequence is of the form n to the power of 4 plus 1.2, where n takes on the values 17, 257, 1297, 65537, and so on. The sequence is listed in the OEIS as a 037896. The given sequence consists of prime numbers for which there are more prime permutations of their decimal digits than for any smaller number. The sequence starts with 2 and continues with 13, 37, 107, 113, 137, 1013, 1237, 1367, and 10,079. This sequence is also known as OES A119535. The given sequence consists of prime numbers of the form Pn hash plus or minus 1, where Pn hash represents the primorial of n. The sequence starts with 3, 5, 7, and continues with larger prime numbers such as 29, 31, 211, 2309, 2311, 30,029, 200,560,490,131, 304,250,263,527,209, and 23,768,741,896, 345,550,770,650,537, 601,358,309. This sequence is a combination of two sequences from the OEIS database, a 057705 and A018239. The given sequence consists of numbers of the form k times 2 to the power of n plus 1, where k is an odd number and k is less than 2 to the power of n. The sequence starts with 3, 5, 13, 17, and continues with several other numbers such as 41, 97, 113, 193, 241, 257, and so on. This sequence is known as OEIS A080076. The given sequence is of the form 4n plus 1, where n is a non-negative integer. The sequence starts with the numbers 5, 13, 17, 29, and so on. These numbers are obtained by substituting different values of n into the equation 4n plus 1. The sequence continues indefinitely, and the numbers listed are the first few terms of the sequence. The given sequence consists of sets of 4 prime numbers where each number is a certain value greater than the previous one. The examples provided are 5, 7, 11, 13, 11, 13, 17, 19, 101, 103, 107, 109, and so on. These sets of primes are known as prime quadruplets and have been catalogued in the OEIS, Online Encyclopedia of Integer Sequences, under the respective references mentioned. The sequence is generated by the formula x to the power of 4 plus y to the power of 4, where x and y are positive integers. The first few terms of the sequence are 2, 17, 97, 257, 337, 641, and 881. This sequence is listed in the Online Encyclopedia of Integer Sequences as a 002645. The sequence mentioned in the question is a list of prime numbers that are the smallest to give at least n primes from x, divided by 2 to x for all x greater than or equal to the respective number in the sequence. The sequence starts with 2 and continues with several other prime numbers. This sequence is known as OEIS A104272. The list provided consists of prime numbers that do not divide the class number of the pth cyclotomic field. The list includes primes such as 3, 5, 7, 11, 13, and so on, up to 281. This sequence is also known as a 007703 in the OEIS, which stands for the Online Encyclopedia of Integer Sequences. The sequence of primes containing only the decimal digit 1 starts with 11 and continues with numbers of increasing length, such as 1111111111111111 19 digits, and 11111111111111111111 23 digits. The next primes in this sequence have 317, 1031, 49,081, 86,453, 109,297, and 270,343 digits. These sequences are listed in the OEIS as A004022 and A004023. The primes of the form 2n plus 1 are the odd primes, including all primes other than 2. Some sequences have alternate names. 4n plus 1 are Pythagorean primes, 4n plus 3 are the integer Gaussian primes, and 6n plus 5 are the Eisenstein primes with 2 omitted. The classes 10n plus d, where d equals 1, 3, 7, or 9, are primes ending in the decimal digit d. The given list consists of prime numbers where both p and p minus 1 divided by 2 are prime. The list includes numbers such as 5, 7, 11, 23, 47, and so on. These numbers satisfy the condition that both p and p minus 1 divided by 2 are prime. The list is a sequence known as a 005385 in the OEIS, which stands for the Online Encyclopedia of Integer Sequences. The given list consists of prime numbers that cannot be obtained by adding any integer to the sum of their decimal digits. These numbers include 3, 5, 7, 31, 53, 97, and so on. The complete list can be found in the OEIS sequence as 006378. The pairs PP plus 6, where both numbers are prime, are 5, 11, 7, 13, 11, 17, 13, 19, 17, 23, 23, 29, 31, 37, 37, 43, 41, 47, 47, 53, 53, 59, 61, 67, 67, 73, 73, 79, 83, 89, 97, 103, 101, 107, 103, 109, 107, 113, 131, 137, 151, 157, 157, 163, 167, 173, 173, 179, 191, 197, 193, 199. These pairs can be found in the OEIS sequences A023201 and A046117. The sequence consists of prime numbers that are formed by concatenating the first n primes in decimal form. For example, the first three numbers in the sequence are 2, 23, and 2,357. The fourth number in the sequence is a 355-digit prime formed by concatenating the first 128 primes that end with 719. This sequence is also known as OEIS A069151. The sequence is of the form 2a plus or minus 2b plus or minus 1, where a and b are positive integers and b is less than a. The first few terms of the sequence are 3, 5, 7, 11, and 13. This sequence is also known as A165255 in the OEIS, which stands for the Online Encyclopedia of Integer Sequences. A Sophie-Germain prime is a prime number p such that 2p plus 1 is also prime. These primes have a corresponding safe prime. The given list contains the first few Sophie-Germain primes: 2, 3, 5, 11, 23, 29, 41, 53, 83, 89, 113, 131, 173, 179, 191, 233, 239, 251, 281, 293, 359, 419, 431, 443, 491, 509, 593, 641, 653, 659, 683, 719, 743, 761, 809, 911, 953. The given list consists of primes that cannot be expressed as the sum of a smaller prime and twice the square of a non-zero integer. These primes include 2, 3, 17, 137, 227, 977, 1187, and 1493. As of 2011, these are the only known Stern primes, and it is uncertain if there are any others. The sequence consists of prime numbers that have a prime index in the sequence of prime numbers. The first few numbers in this sequence are 3, 5, 11, 17, 31, and so on. The sequence continues with 41, 59, 67, 83, 109, 127, and so on. The sequence is denoted by OEIS as A006450. The 15 supersingular primes are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 41, 47, 59, and 71. These primes have special properties in the field of elliptic curves and are of interest in number theory. The given sequence is of the form 3 times 2 to the power of n minus 1, and it includes prime numbers. The second sequence is of the form 3 times 2 to the power of n plus 1, and also consists of prime numbers. Both sequences have been documented in the OEIS, Online Encyclopedia of Integer Sequences, with their respective identifiers. The given sequences are examples of sets where either p plus 2, p plus 6 inches, or p plus 4, p plus 6 inches are all prime numbers. These sequences include numbers like 5, 7, 11, 7, 11, 13, 11, 13, 17, and so on. These sets are known as prime triplets and can be found in the OES sequences a 007529, a 098414, and a 098415. The given sequence consists of prime numbers that remain prime when the leading decimal digit is successively removed. The sequence starts with 2, 3, 5, 7, and continues with other primes such as 13, 17, 23, 37, and so on. The sequence is known as OEIS as 024785. The sequence consists of prime numbers that remain prime when the least significant decimal digit is successively removed. The first few numbers in the sequence are 2, 3, 5, 7, 23, 29, 31, 37, and so on. The sequence continues with more prime numbers that follow this pattern. The concept of left truncatable and right truncatable primes refers to prime numbers that remain prime when digits are removed from either the left or right side. There are exactly 15 such primes: 2, 3, 5, 7, 23, 37, 53, 73, 313, 317, 373, 797, 3,137, 3,797, and 739,397. The given sequence consists of pairs of prime numbers represented as p plus 2, where both numbers are prime. The sequence starts with the pair 3, 5, and continues with various pairs such as 11, 13, 17, 19, 29, 31, and so on. This sequence is known as OE-ISA 001359 and OE-ISA 006512. The list provided consists of prime numbers for which the decimal expansion of 1 divided by the prime number has a unique period length. These primes include 3, 11, 37, 101, 9,091, 9,901, 333,667, 909,091, 99,901, 9,999,000,001, 9,999,901,000,001, 909,090,909,000,090,091, 1,111,111,111,000,000, 111,111,111,111,111, 1,111,111,111,111,111,111,111,111,111, and 900,900,900,900,900,991. This sequence is known as OEIS 040017. The given sequence is of the form 2n plus 1 divided by 3. The first few terms of the sequence are 3, 11, 43, 683, 2,731, 43,691, 174,763, 2,796,203, 715,827,883, 2,932,031,043,403, 768,614,336,404,564, 651, 201,487,636,602,438, 195,784,363,363, 845,100,401,521,529,000,334,311,355,455,000, 355,470,000, 251, 56,713,728,000, 156,410,000, 572,291,000, 12,386, 280,000, 352,403. The corresponding values of n are 3, 5, 7, 11, 13, 17, 19, 23, 31, 43, 61, 79, 101, 127, 167, 191, 199, 313, 347, 701, 1,709, 2,617, 3,539, 5,807, 10,501, 10,691, 11,279, 12,391, 14,479, 42,737, 83,339, 95,369, 117,239, 127,031, 138,937, 141,079, 267,017, 269,987, 374,321. The statement describes a condition for a prime number p greater than 5 to divide a Fibonacci number. It states that if p squared divides the Fibonacci number fp minus p divided by 5, where p divided by 5 is the Legendre symbol defined as 1 if p is congruent to plus or minus 1 modulo 5 and minus 1 if p is congruent to plus or minus 2 modulo 5, then p is a Wall-Sun-Sun prime. However, as of 2018, no Wall-Sun-Sun primes have been discovered. The given list consists of prime numbers that, when any of their digits in base 10 is changed to a different value, will always result in a composite number. The list includes numbers such as 294,001, 505,447, 584,141, and 4,393,139. These numbers have been cataloged in the OES sequence 050249. The summary provides a list of primes p such that a p-1 is congruent to 1 modulo p squared for a fixed integer a greater than 1. It includes the values of p for different values of a along with their corresponding OEI sequences. The summary also mentions that as of 2018, these are all the known Wieferich primes with a less than or equal to 25. The primes p for which p squared divides p-1 factorial plus 1 are 5, 13, and 563. These primes are also known as Wilson primes, and as of 2018, they are the only known Wilson primes. The binomial coefficient 2p-1 choose p-1 is congruent to 1 modulo p to the power of 4 for primes p. The only known primes that satisfy this condition are 16,843 and 2,124,679, which are also known as Wolstenholme primes. The given sequence is of the form n times 2 to the power of n-1. The first few terms are 7, 23, 383, and so on. The sequence continues with larger numbers such as 32,212,254,719, 2,833,419,889, 721,787,128,217,599, and 1,958,459,827, 775,699,263,024,511. The sequence is known as OES, 050918. In conclusion, this article presents a comprehensive overview of prime numbers, including their calculations, formulas, and various named forms. For further details, please refer to the article itself.